So this particular one is going to tell us about the two forms of linear functions. We are really familiar with the slope-intercept form, the slope-intercept form, but we're going to be introduced to the standard form. All functions have a standard form, and we can get some information from that standard form, but then all functions have other forms that are a little more useful and give us information. So we're going to talk about each of the forms. The slope-intercept form we've been dealing with since the beginning of the year. And we know that the m is the speed, it's the slope. So if we're looking at a graph of a line, it's going to talk about the rise over the run. And then also the rate of change. So if it's going 5 miles every 2 minutes, then that's the rate of change. The b is always the y-intercept. And that's where it crosses the y-axis. So x is always 0 for the y-intercept no matter what the function. And then often the b in a word situation is the starting amount, how much they started with. It might also include day 1 or figure, no, day 0, I'm sorry, day 0 or figure 0. If we're using the slope-intercept form to graph, we could plug points in and we could create a table of values if we wanted to, and we could put 0 in for x and we'd get -6 and et cetera, et cetera, et cetera. But since we already have one of the points here at, I'm going to blow this up. I have it at -1, 2, 3, 4, 5, 6. There we are at -6, and we know that it grows 2 for every 3, so it rises 2 for every 3 it runs, up 2 over 3, up 2 over 3, and so we know there's 0, -6, and another easy number is 3, -4, and 2, -2, etc. And so the graph of this line, y equals 2/3 x minus 6, we can graph it with the table of values or go ahead and just graph it with the information from the equation. The standard form doesn't give you the slope very easily, but you can easily find the x and the y-intercepts, because we know the x-intercepts are when y is 0. We can go ahead and replace the y. And we're doing this one, make this one blue. We're going to go ahead and replace the y with 0, and you can easily do this in your head. You don't have to actually write it down. 2x minus 3 times, I'm going to replace the y with 0. And that is going to be equal to 6. So when I multiply anything by 0, it zeroes out. So all I really have to think about is the 2x equaling 6. So I know my x-intercept is going to be at 3. You can do the same thing with the y-intercept without writing anything down. The way I think about it is I'm like, well, if the y-intercept is always when x is 0, so I'm going to let x equal 0. 2 times 0 is 0. I don't even have to look at that anymore. So now I just have to solve -3y equals 6, which is -2, because 6 divided by -3 is -2. So you can easily find the x-intercept and the y-intercept without doing a lot of math. I don't write everything down, actually. The standard form, it's not that easy to find the slope. It's not right in the equation, but you can easily find the slope one of two ways. One way is to use those x and y-intercepts. So we know that the x-intercept is when y is 0, so 2x equals 6. There we go, it's 3. And we know that the x-intercept, the y-intercept is when x is 0, so y is going to be negative 2. And then we can go ahead and use our slope triangle, our idea of rise over run, change in y over change in x. So we can go ahead and we're going to go ahead and do y2 minus y1 over x2 minus x1. So I'm just going to let negative 2 minus 0 and 0 minus 3. So the slope of this line is negative 2 minus 0, which is negative 2, and 0 minus 3 is negative 3. So the slope is 2/3. It's a fairly easy way to do it, but you might find that it's easier to do it the other way, which is if you take the standard form and you get it in y equals form, you'll end up with y equals mx plus b, and you'll have the slope and the y-intercept right in front of you. So we're going to go ahead and solve for y. We want it to be y equals form. So to do that, we have to get the y term by itself. We're going to get rid of the 2x. We're going to subtract 2x from both sides. We have negative 3y is equal to negative 2x plus 6. Now, negative 2x plus 6 don't go together. They're not like terms. This is weird that we're leaving a variable. It's a new thing to do. But we're really trying to get, once again, the y by itself because we want it in y equals form. So the last thing we have to get rid of is the negative 3 times y. So we're going to go ahead and divide everything by negative 3. And then we're going to end up with the y by itself. So we have y equals negative 2 and negative 3 is positive 2/3 x minus 2. So you can rewrite the slope-intercept form, rewrite the standard form in a slope-intercept form using your equation solving skills. So with standard form, you can either graph it using the intercepts, which I think is pretty easy. So once again, I'm going to find the x-intercept when y is 0. So when y is 0, all I have to do is solve for x equals 8. X divided by 4 is 2. And then I'm going to find the y-intercept, which is always when x is 0. So 4 times 0 cancels that all out. Negative 2 times y equals 8. So y is going to have to equal 8 divided by negative 2, which is going to be negative 4. So now I just have to graph 2 points, because when you have a line, all you need are 2 points to make the accurate line. I'm going to blow this up a little bit because it's hard for me to. So we have 2, 0 here. And we have 0, negative 4 there. And we can go ahead and graph the equation that way. We're going to graph the exact same equation using the other method on the next slide. You can always decide what it is you want to do, but if we wanted the slope, you could take it directly from here as well. So if you wanted to find the slope and the y-intercept, you could graph the line and then find it that way. So this one has a slope of up 4 over 2. So it's 4 over 2, which is 2. And then the y-intercept is at 0, negative 4. So if you wanted to graph your standard form and find the slope and the y-intercept that way, that's an option as well. So the last way of graphing from standard form is to rewrite it, the slope-intercept form, and use what you know there. So once again, that means we're trying to get the y by itself. And so we're going to start by getting rid of that 4x. And we're going to get rid of the whole thing. So we're going to subtract the whole thing from both sides. Negative 4x, we're subtract 4x from both sides. The 4x and the negative 4x, they cancel each other out. And all we have left on the left side is negative 2y. On the right side, these are not like terms, so we're going to leave them as they are. Negative 4x plus 8. And then once again, we need to get the y by itself, and so we're going to divide everything by negative 2. Every term. That one, that one, that one. So when we're done dividing each of the terms, it'll be in slope-intercept form, and then we can use the slope and the y-intercept to help us graph. Negative 2 divided by negative 2 is y, just what we're looking for. Negative 4 divided by negative 2 is 2. X minus 4. If you remember on the previous slide, it had a y-intercept of negative 4 and a slope of 2. So it doesn't matter what method you use, you're still going to get the same thing. So y-intercept is at negative 4. And then the slope of 2, I can go up 2 over 1, up 2 over 1, and I'm going to end up with the graph of the function. So there's lots of ways to get where you need to go, but if you have the standard form, it's easy to find the x-intercepts, it's easy to rewrite it, or it's not necessarily easy for everybody, but you can rewrite it into slope-intercept form to get what you need. If you want to practice, go back to a slide before I start talking, do it yourself, and then check with my blah blah blah. Anyway, bye.